Okay guys, so we have to today start with this new and the last conic section for our discussion, which is hyperbola. Now when I am talking about hyperbola, if I associate it with the connection with the conic section, what was the definition of hyperbola based upon eccentricity? It said that the locus of a point, hyperbola is nothing but the locus of a point which is moving in a plane in such a way, so its movement is governed by a certain condition. What is that condition? In such a way that the ratio of its distances or the ratio of its distance from a fixed point, ratio of its distance from a fixed point, and that fixed point you know is called focus, such that the ratio of its distance from a fixed point to its distance from a fixed line, and what is that fixed line called? It's called the directrix. From a fixed point to its distance from a fixed line is constant, that is greater than unity. So when a point, now this is a moving point, so when a point is moving such that there is a fixed point in picture called focus, there is a fixed line in picture called the directrix. So when a point is moving such that the ratio of its distance from this focus to its distance from this directrix is always constant, and this is something which is important, that the constant has to be greater than 1. Unity is nothing but 1. So the constant has to be greater than 1. What is this constant called? Eccentricity, right? Denoted by small e. And therefore in terms of eccentricity, if I associate hyperbola's definition with the definition of conic section, then what am I going to say? That thus hyperbola is a conic section with eccentricity greater than 1. If the definition of conic section is clear to you, you can simply write hyperbola to be a conic section with eccentricity greater than 1. Because what is a conic section? Nothing but the locus of a moving point which is moving in the plane in such a manner that the ratio of its distance from a fixed point to the distance from the fixed line is constant, that is it, known as eccentricity. And when that eccentricity is greater than 1, the conic section turns out to be called a hyperbola. So if I am saying this is a point S, say this is my fixed point called focus. If this is my focus or the fixed point, and I have this line, say ZZ dash, to be the fixed line called the directrix, and this is a point P on the hyperbola, point P is on the hyperbola, then in that case, the distance of P from this fixed line to its distance of P from the fixed point to its distance from the fixed line, this ratio is going to be constant. PS upon P, say this is T, is equal to constant known as E, and E is greater than 1. So the constant which is coming out to be as the ratio of the distance of P from the fixed point to its distance from the fixed line should be a constant strictly greater than 1. And always remember, we are going to use this many a times, that PS actually can be determined in terms of PT, or PT can be determined in terms of PS. I can say PS is E times PT. Clear? So if you know PT and you know P is a point on the hyperbola, then PS is equals to E times PT. This is about the introduction to hyperbola and what is the meaning of that. Now if I move ahead as to how actually would a hyperbola look like if it has been governed by this condition that any point lying on the hyperbola, the ratio of its distance from a fixed point to its distance from a fixed line has to be a constant which is greater than 1. In this case, how actually should the points, all the points which are satisfying this condition corresponding to a fixed point and a fixed line should actually result in which curve? That means, if I have a fixed point and I have a fixed line corresponding to that focus and that directrix, what are all the points which satisfy the given condition for a hyperbola? Let's see. So basically, suppose this is the fixed point. So this is my focus, and suppose this is the fixed line, or let me write directly now that you've understood the directrix. Say Z1, Z1 dash. In this case, all the points such that the ratio of their distances from S upon its distance from this directrix is constant greater than 1 is going to come out to be this as well as this. Now what is this trying to say? These two lines that you can see, the curves that you can see, basically this curve and this curve, this is the collection of points which satisfy this condition of hyperbola, that the ratio of the distance from a fixed point called focus to its distance from a fixed line called directrix is constant greater than 1. It is these points lying on this and this curve. Now, if you can carefully see, any point if you pick up, its distance from this focus to its distance from this line, that means I am talking about the ratio, distance from this focus to its distance from this line is constant, which is equal to eccentricity which is greater than 1, right? Same is the scenario with any point here also. Any point here, if you pick up its distance from this focus and its distance from this line, suppose this is T and this is a perpendicular, then, and suppose this is P dash, then P dash S upon P dash T is equal to PS upon PM, which is E, that is greater than 1. Now somebody can ask that what is the compulsion to take this point only as the focus and this point as the directrix? Yes, there is no point absolutely. I can also take over here, exactly at a similar distance, I can take over here, say S dash as my focus. Suppose I fix this point. Suppose I fix this point and say somewhere here is the fixed line. Suppose I say this is my directrix. For a minute, just forget that this is the focus and this is the directrix. If this was the focus and this was the directrix, I was getting all these points. But apart from, or I should say rather than keeping this as the focus, this as the directrix, if you keep this as the focus and this as the fixed line, that is directrix, again you are going to get the same curve. Are you understanding? That means this figure known as hyperbola has two foci and two directrices. If you keep this as the fixed point and this as the fixed line, you have this and this, both these curves actually making one curve known as hyperbola. But apart from that, if somebody is interested in keeping this as focus, this as directrix, again the same figure will be plotted under the condition that is governing the construction of hyperbola. Okay, that means this figure is actually made up with two, or in context with two fixed points and two fixed lines. So this hyperbola that it is called is having two foci and two directrices. Understood? This is first focus, first directrix, second directrix. Now how do you perceive it in the Euclidean plane? If you join both the foci, suppose that you join both the foci, when you join both the foci and actually extend this line, name this as the x-axis. Clear? Now what you do, suppose this point is A and this point is A dash. Or if you want, you can keep this as B, this as B dash. In this case, if I talk about these 2 points, midpoint of this would be somewhere here. A line perpendicular to the x-axis that we have made, a line perpendicular to the x-axis bisecting A dash or bisecting B dash, both ways, draw it. This is your y-axis. Understanding? And this point obviously is going to then be the origin. This figure that you can see is what is called a hyperbola. Understood? So if this is the hyperbola, or I should say that this is the curve or this is the conic section, which is nothing but the collection of all the points which are satisfying this condition, then this is that figure. Clear? Now comes a question as to, we have obtained the general equation of a circle, we have obtained general equation of parabola, we have obtained general equation of an ellipse. How to obtain the general equation of a hyperbola? Exactly on the same lines like that we did in the case of ellipse, we proceed to do in the case of hyperbola as well. What is that same condition? Let's recall. If you talk about ellipse, we first understood ellipse as the conic section with eccentricity between 0 and 1, that means fractional eccentricity. But if you remember, the geometrical making of ellipse actually gave us another definition. What was that? That the ellipse is nothing but the locus of a point which is moving in a plane in such a manner that the sum of its distances from two fixed points is always constant. And that constant was equal to the length of the major axis, which was equal to 2a. And with that, we actually proved the equation or standard equation of the ellipse, which was x square by a square plus y square by b square equals 1, where b square was related with a square and the eccentricity. Over here also, in the case of hyperbola, we have an alternative definition to the hyperbola. What is it? A hyperbola is the locus of a point. A hyperbola is the locus of a point moving in a plane in such a way that the difference moving in a plane in such a way that the difference of its distances from two fixed points is always constant. So there it was sum, here it is difference. No change at all after that. So there you considered plus, here you are going to consider minus, rest all is the same. When I say rest all is the same, I in fact mean this constant is also same. Over there, how you started the proof of getting the standard equation of ellipse? You wrote that ellipse is the locus of a point moving in a plane in such a way that the sum of its distances from two fixed points is always constant, equal to 2a. You just assumed that. Then in the end of that section, we actually proved what 2a was and how this is actually coming out to be 2a. Fine. Over here also assume it to be equal to 2a. This in the case of hyperbola, assume it to be equal to 2a. One thing is this assumption. Other thing that the assumption was in the case of ellipse was the coordinates of the two fixed points. The coordinates of the two fixed points. Right? These two are my fixed points. As you can see, if I apply this definition in the tracing of my hyperbola, I can say keep S and S dash as the two fixed points, then the locus of this point P moving in this plane in such a manner that the difference of its distances from these two fixed points is always constant. That is also going to give me the same tracing. Obviously, both the definitions are equivalent. So what you can do is keep these two as the fixed points which are my foci and assume the coordinates to be AE, 0 minus AE, 0. Exact same coordinates as that in the case of ellipse. Okay? Just assume this. The proof, in fact, if you remember, the proof is exactly the same to find out the coordinates of S and S dash, which are the two foci. So you don't need to assume actually, we have done the proof of how S and S dash have coordinates AE, 0 and minus AE, 0. Just replicate it over here and you have these two as coordinates of the two fixed points or the two foci. So assuming this and assuming these coordinates, you are in actual position to derive the standard equation of the hyperbola, and that comes out to be what? Let me directly tell you, because the proof is exactly the same and we've done it in the case of ellipse. Standard equation of hyperbola is, it comes out to be x square by a square minus y square by b square equals 1. That's the only difference. There it was x square by a square plus y square by b square. Here it is minus y square by b square, where, now this is utmost important, relationship between a, b and the eccentricity. So this b square was also assumed as some quantity being equal to b square, like in the case of ellipse. So what is that quantity? In the proof you can see when you are going to do it, b square is equals to a square into what? There it was a square into 1 minus e square, right? But 1 minus e square came out to be positive because e was less than 1 and greater than 0. Because e was less than 1, we said 1 minus e square is positive. But right now in the case of hyperbola, e, that is the eccentricity, is greater than 1. So 1 minus e square will be negative. 1 minus e square will be negative. A square is non-negative. Non-negative into negative is negative, but b square is non-negative. So how can a negative quantity be equal to non-negative quantity? I cannot write 1 minus e square over here. You are going to get e square minus 1. Because e is greater than 1, e square minus 1 is positive. Understood? First question says if there is a point a comma minus a which lies inside this given circle, then a lies in which interval? The moment I say that a is lying inside the interval, this point is lying inside the very circle, we have the criteria with us, which is S1 is less than 0, right? So when a comma minus a lies inside the circle, S1 is less than 0. What is S1? In place of x, you put x1, in place of y, you put y1. Here x1 is a and y1 is minus a, and this LHL left hand side basically is going to be less than 0. So you get x square plus y square, which makes it a square plus a square minus 4 into a plus 2 into minus a minus 8 is less than 0. Because the point is lying inside the circle. So its coordinates are going to not satisfy the equation of the circle, but when you plug in the coordinates of the point in the equation of the circle, you get less than 0 and not equal to 0. So you get 2a square minus 6a minus 8 is less than 0, which means a square minus 3a minus 4 is less than 0. Right? So what you need is a square minus 4a plus a minus 4 is less than 0, isn't it? So you get a minus 4 plus 1, a minus 4 is less than 0. So you get a minus 4, a plus 1 is less than 0, which if you plot on the number line, you get this is minus 1 and this is 4. If you plug in anything less than minus 1, you actually get positive. So you don't take this region. Here you get negative, here you get positive. So it is for x belonging to open or small a belonging to open minus 1, 4 interval, for which this is less than 0 or this is satisfied. So a should come from this interval such that a comma minus a lies inside this circle. So it is what? Minus 1 comma 4 open interval. Next question says what? It says that if the line y equals mx, so this line is not intersecting this circle, then, so it is already given to us that this line is not intersecting the circle. That means it is not even tangent, nor is it basically crossing through the circle, intersecting it at two distinct points. It is literally outside the circle. That means if I talk about the perpendicular distance of the line from the center of the circle, it is obviously greater than, strictly greater than the radius. So what is the perpendicular distance of that line from the center of the circle? The center of this circle is minus 10 comma minus 10. And the line is basically y equals mx, which means mx minus y plus 0 equals 0. So perpendicular distance is greater than the radius. What is the radius? Radius is under root 180 whole square. So under root 180 is the radius. This is the center and that's my line. Perpendicular distance of the line from the center is m into minus 10 minus minus 10 whole upon under root m square plus minus 1 whole square. So m square plus 1. This distance is greater than the radius. Fine. So what you get from here is if you square both sides, you basically get this is 100, then this is 1 minus m whole square, because 10 comes out common, you square it, you get 100, 1 minus m whole square whole upon m square plus 1 is greater than 180. So next what you get is, this is 100 upon 180 is greater than m square plus 1 upon 1 minus m whole square. From here you get this is 5 and this is 9. So you basically get 5 times 1 plus m square minus 2m is greater than 9m square plus 9. So this gives you 5 plus 5m square minus 10m minus 9m square minus 9. Now 5m square minus 9m square gives you minus 4m square minus 10m minus 4, because 5 minus 9 gives you minus 4. This is greater than 0, right? You take out 2 common, you get minus 2m square minus 5m minus 2 is greater than 0, or 2m square plus 5m plus 2 is greater than 0. Isn't it? Or I should write over here less than 0. Why? Because I am taking out minus sign common, right? So if minus of this is greater than 0, this term is less than minus of 0, which is 0 itself. So now when you try to open this up, what you get is, this is 4m plus m plus 2 is less than 0. From here you can take out 2m common, you are left with m plus 4, and then you have, this is m plus 2, you take out 2m common, you are left with m plus 2 plus 1 m plus 2. This is less than 0. Again you get 2m plus 1, m plus 2 is less than 0. On the number line when you plot, you basically get minus 2 and minus 1 by 2. And you obtain, this is the region where m should belong to satisfy this condition. So m should come from minus 2 comma minus 1 by 2. Understood? That is the very range of m. Clear? Third question says what? It says that the equation of the circle passing through this point and the points common to the two circles, this is what circle? Now here the concept comes into picture, that if there is a circle passing through the intersection of these two circles, its equation is given by x square plus y square minus 6x plus 8y minus 16 plus lambda times the other circle, which is x square plus y square plus 4x minus 2y minus 8 equals 0. So that's how the equation of the circle is understood. What is the exact equation? For that you have to understand that this circle is passing through the point 1 comma minus 3. So in place of x if you put 1, and in place of y if you put minus 3, you get the value of lambda, right? In place of x you put 1, in place of y you put minus 3. Okay? And this is equal to 0. You solve this, you get lambda is equal to 3. And therefore equation of circle comes out to be x square plus 3x square, that is 4x square, y square plus 3y square, that is 4y square, minus 6x plus 12x. See, minus 6x plus 4 into 3, 12x. So 12 minus 6 is 6. Then you have plus 8y minus plus 8y minus 6y. So 8 minus 6 gives you 2. And then you have minus 16 minus 24, which is minus 40. Okay? This is the very equation of the circle, or in short you can say 2x square plus 2y square plus 3x plus y minus 20. So 2x square plus 2y square plus 3x plus y minus 20 is the correct answer. Next question says that if the line y equals mx plus c touches the parabola which is given by this, then what are the conditions which c is going to satisfy? Now see, if you remember y equals mx plus c, y equals mx plus c touches the parabola y square equals 4ax when, or I should write lambda, y equals mx plus lambda touches the parabola y equals 4ax when lambda was equal to a by m. Similarly over here I can manipulate the equation of this particular line. It can be written as y equals to m of x plus a plus c. Now a into m is extra, so I remove that. So this is playing basically the role of my lambda, because the equation of the parabola is 4a x plus a. So x plus a, x plus a. This line is going to touch this parabola when lambda will be equal to a by m, that is c will be equal to a by m plus am. It is this condition which is going to make sure that the very line is touching the parabola, which is what? A by m plus am. Clear? A by m plus am. Next question says what? It says that the normals at the ends of the lattice rectum of this parabola intersect at an angle of what? Let's try to find this out. If I talk about this parabola's y square equals 4x parabola's lattice rectum, what are the endpoints of the lattice rectum? A comma 2a and a comma minus 2a. Fine. The equation of the normal passing at this point on this parabola is what? It is given by y minus y1, this is y1, y minus y1 equals minus y1 by 2a x minus x1. So 2a gets cancelled, you are left with y minus 2a plus x minus a equals 0. So this gives you y plus x minus 3a is 0. Similarly, another one, there is another normal which is passing through the point a comma minus 2a. Its equation will be y minus y1 equals minus y1. So minus of minus 2a is 2a, minus y1 by 2a x minus x1. So this gives you y plus 2a minus x plus a equals 0, which is y minus x plus 3a equals 0. If you can very easily get, the slope is, what is the slope? This is y plus x. What is the slope? It is minus 1. And what is the slope over here? Slope is minus 1 or 1 upon 1 basically, I should say, so it is 1. You can see that the product of the slope of these two normals is negative, that means they are perpendicular to each other. So the angle of intersection between them will actually be equal to 90 degrees. That is your answer. Fine. So we just compute the very equation of the two normals and then we calculated the slope. The product of the slopes was coming out to be minus 1, which means that they are perpendicular to each other, therefore the angle is 90 degrees. Next we have that the angle between the tangents drawn from this point to the parabola y square equals 4x is what? Now see, I am saying let the slope of the tangent be equal to m. And the tangent's equation is what? Y equals mx plus 1 by m. It is a by m, but a is 1, so this is 1 by m. Now this is actually passing through 1 comma 4, so this is 4 equals m plus 1 by m, which means 4 equals m square plus 1, or 4m equals m square plus 1. So this is m square minus 4m plus 1 equals 0. Suppose this has two roots, m1 and m2. Then clearly m1 plus m2, sum of the roots is minus b by a, so that is 4, and product of the roots is c by a, that is 1, right? Now what is the very angle between these two tangents? I can say let the angle be theta, then tan theta is m1 minus m2 upon 1 plus m1 m2. But I don't explicitly know what is m1 and m2, what I just know is m1 plus m2 and m1 into m2. So I write down this as m1 plus m2 whole square minus 4 m1 m2. That's how we can write this, whole upon 1 plus m1 m2. Understood? So this is m1 plus m2, that is 4 square, which is 16, minus 4 upon 1 plus 1, that is 2. And this actually gives you root 3, which eventually brings tan theta is root 3, and so theta is pi by 3. That's how we compute the very angle between these tangents, which is pi by 3. Clear? Next question is, tangents are drawn at the points where the line this is intersected by the parabola y square equals 4ax. The coordinates of the point of intersection of the tangents are what? So over here, understand, basically tangents are being drawn at points where this line is intersected by the parabola. That means this line is actually happening to be the chord of contact of the two tangents at the point x1 comma y1. I don't know what that is. Some point x1 comma y1 is there, and where these two tangents are intersecting, and this is actually the chord of contact, right? So what is the actual equation of the chord of contact? It is y1 equals 2a x plus x1. x1 comma y1 is the point at which they are meeting. This is the actual equation of the chord of contact of the two tangents intersecting at x1 comma y1, but it is given to me as lx plus my plus n equals 0. This is given to be as the equation of the tangent. Let me write it in standard form. This is 2ax minus y1y plus 2a x1 equals 0. So obviously both of them are representing the same equation, same line. So what you get is that 2a by L is equals to minus y1 by m equals 2ax1 by n. If you compare these two, what you get as x1 is 2a gets cancelled, x1 comes out to be n by L, and y1 comes out to be what? Now y1 comes out to be 2am by L, or minus 2am by L, right? This is 2am by L and minus sign. So you basically have your very coordinates, that is n by L, comma minus 2am by L. This is the point at which the two tangents are intersecting, and Lx plus my plus n is the equation of their chord of contact. Next question what we have is the equation of the chord of this ellipse is bisected at 2 comma 1 is what? Let's see. Now this is very direct. Ellipse is given to you, equation of the chord bisected at a certain point. You know it is equal to, it says t equals s1, right? So it is x1. So x into x1 is 2, y1 is 1. So 2x by 36 plus y into 1, y by 9 minus 1 equals x1 square, that is 2 square by 36 plus 1 square by 9 minus 1. So you basically get 2x plus 4y minus 36 equals 4 plus 4 minus 36. So what is it that you get? You get 2x plus 4y equals 8, or you get x plus 2y equals 4, right? What you get x plus 2y equals 4 or x plus 2y minus 4 equals 0 as the very equation of chord bisected at a given point for the ellipse. Next question, we have the equation of the tangents to the hyperbola this which are perpendicular to this line are what? So let's try to understand this. Now over here, see what is happening. Suppose tangent has slope m. Now this tangent is perpendicular to the line x plus 3y equals 2. What is the slope of this line? It is minus 1 by 3 minus coefficient of x upon coefficient of y. And you know that this tangent is actually perpendicular to this tangent is perpendicular to this particular line. So the product of their slopes is minus 1, right? So what you get basically is that m is equal to 3. Now m is 3. Also, if I am talking about this equation, it is the equation of the hyperbola y. This I am written as x square minus y square by 3 equals 3 by 3, which is 1. So you get a square, x square by a square is 1, b square is 3. So what is the equation of the tangent? The equation of tangents becomes y equals mx plus minus under root a square m square minus b square, which is y equals mx is 3x plus minus under root a square m square. So 1 into 3 square minus b square is 3. So y equals 3x plus minus root 6. This is what is the equation of my tangents, y equals 3x plus minus root 6. Clear? Next what we have is that the equation of the hyperbola whose asymptotes are given to you and vertices are given to you is what? And this is pretty simple and nice, that if you know the equation of both the asymptotes, equation of hyperbola becomes what? Equation of hyperbola becomes 3x plus 5y multiplied by 3x minus 5y plus some constant equals 0. That's what is the equation of the hyperbola if you are aware about the two equations of the asymptotes. Now over here understand, it is given that it passes through 5, 0 minus 5, 0. 5, 0, if this passes through, you get 5 into 3, 15 plus 0 into 15 minus 0. So 15 into 15 gives you 225, 225 plus lambda is 0, lambda comes out to be minus 225. When you plug in the very value of lambda in here again, what you get is a plus b, a minus b, which is a square minus b square equals 225. Clear? So 9x square minus 25y square equals 225 is the very equation of my hyperbola. 9x square minus 25y square equals 225, and that completes our discussion over the questions. Please practice them nicely. That's it from my side. Thank you.